In this video, we're going to talk about infinite series. So let's just think for a minute if we have this number line from 0 to 10, and we're going to start at the position of 10 here. And each time we're going to move halfway towards 0. So in my first move, I'm going to go from 10 to 5, half the distance. So I'm going a distance of 5. And then I'm going to go halfway from 5 to 0. So I'm going to go 2.5. So I'm going to go a distance of 2.5. So we're going to add 2.5 to that. Then I'm going to go half of the distance from 2.5 to 0. So we're going to go 1.25. So we're going to add 1.25 to that. And then we're going to go half of that distance, which is going to be 0.75. So plus 0.75. And then we're going to go half of that distance, which is 0.375. And then we're going to keep going half, 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 half. Theoretically, we will never get to 0 because we can keep zooming in and going smaller, 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 smaller. So we're going to keep going to infinity. But if we think about this, if we keep going to infinity, then actually we're going to cover almost the entire distance from 10 to 0. Eventually, we're going to go from 10 to 0, and we will get so close to 0 that essentially we will be at 0. So we've covered the entire distance of 10. So if I started adding all of these numbers up, we should get a value of 10. So even though technically we're going to infinity here, we can discuss the summation of that because we cannot go past a distance of 10 because we're still staying in between 0 and 10 on the number line and we're not overlapping any distances. So if we look at a couple of examples here of infinite summations, we're going to determine if the series converges or diverges. So if it converges, it means that it has a sum. If it diverges, that means that there's no sum. It just goes forever and it's either getting very, very large or very, very small. We're going to do this by finding partial sums. Remember, we talked about partial sums before. So here on this first example here, our first partial sum would just be the first term, so 0.1. And then our second partial sum would be the 0.1 plus the 0.01, which is going to give us 0.11. And then my third partial sum is going to be 0.1 plus 0.01 plus 0.001, which is going to give us 111, so 3 ones. So if I look at my fourth partial sum, adding up all 4 of these terms, which is going to give us 0.1111. So hopefully you're seeing the pattern here. So my fifth partial sum is going to be 0.11111. So assuming that the pattern continues, we can find the infinite summation, which would be 0.1 repeating or 1/9. So looking at example B here, my first partial sum is going to be 10. And then my second partial sum is going to be 10 plus 20, so 30. And then my third partial sum is 10 plus 20 plus 30. Which is going to give us 60. My fourth partial sum is the 10 plus 20 plus 30 plus 40, which is going to give us 100. My fifth partial sum, so now I'm going to add 50. So I'm going to have the 100 plus the 50 is 150. So my numbers here just keep getting really, really large. So we would say that this one diverges, which means that the infinite sum does not exist. All right, and then if we look at this last example here, my first partial sum would just be the 1. My second partial sum is going to be 1 minus 1, which is going to give me 0. My third partial sum is 1 minus 1 plus 1, which is going to give me 1. My fourth partial sum would be 1 minus 1 plus 1 minus 1, which is going to give me 0 again. My fifth partial sum would be 1 minus 1 plus 1 minus 1 plus 1, which is going to give me 1. So the pattern here is that we're alternating between a sum of 1 and a sum of 0. So again, this would be a divergent summation. So my infinite sum does not exist. So as you can see, sometimes our infinite summation will have an answer and sometimes it doesn't, in which case we call it divergent. When it does have an answer, then we call it convergent. So here we're going to determine if the sum is convergent or divergent. So we're going to start by just kind of looking at the pattern here. So if I plug 1 in for n, we're going to get 6 plus 3, which is 9. Plus if I plug 2 in for n, I'm going to get 6 plus 6, which is 12. Plug 3 in for n, we're going to get 15. Plug 4 in for n, we're going to get 18, etc. So hopefully from that you can see that this is arithmetic, and each time I'm adding 3. So if we think about the formula for finite summation of arithmetic, so we have finite summation. I'm going to use this formula, 2 times the first term plus d times n minus 1, because we don't have a final term because we're summing to infinity, so I can't use the formula that has the last term in it. So if we think about this, we got n over 2 here. We don't know how many terms we're summing because technically we're going to infinity. 2 times the first term, I know my first term is 9, so 2 times 9, plus I know my constant difference is 3, so times 3 plus 3 times n minus 1. So now I have a formula for my infinite summation using the finite summation. So if we look at the graph of this, we can kind of make some decisions about it. So putting that formula into my y equals, I'm going to take a look at the graph of that. What I can see from this graph is that to the right it's going up forever. So as my position gets larger, my graph is just going to positive infinity, which means as my n value gets larger, my terms are getting larger, my summation is getting larger. So that tells me that this is divergent. All right, so looking at this second example, we're going to do similarly. I'm going to plug 1 in for n, so that's going to be 4 minus 2 times 0, so just 4, plus when we plug 2 in for n, we're going to get plus 2, plus I'm going to plug 3 in for n, 0, plug 4 in for n, we're going to get negative 2, etc. So again, what we see here is that this is arithmetic, and my d value is negative 2 because I'm subtracting 2 each time. So again, completing the formula like we did on the last one, we're going to have n over 2, 2 times the first term, so 2 times 4, minus 2, because I'm subtracting 2, my d value is negative 2, times the n minus 1. And then again, we're going to look at this graph. So putting in the formula for the finite summation, and then looking at what happens towards the extreme. So again, the graph is giving us a parabola, and as we go to the right forever, this graph is going down forever. So my sum is going to get infinitely small. So again, this would be divergent. Both of these were arithmetic summations or arithmetic series. One had a positive d value, one had a negative d value. So from this, what we can see is regardless of what kind of arithmetic sequence or summation I have, when I look at the finite summation formula, I'm going to have a parabola which is either going up forever or down forever on the right-hand side. So every arithmetic infinite series is divergent. Taking a look at these two examples, we can see that my variable is in the exponent, so these are geometric summations. So we're going to do a similar procedure to what we did before. So since these are geometric, I'm going to fill in what we know to the finite geometric summation formula, and then we're going to look at the graph and see if we can determine the end behavior of that. So again, I'm going to kind of look at what the pattern is here. So if I plug 1 in for n, I'm going to get 2 times 7/9 to the first power, so that's going to be 14 over 9. Plus, and then we're going to get 2 times 7/9 to the second power. So this will be 98 over 81. Then when we plug 3 in for n, we're going to get 686 over 729, etc. So what I can see from this is that my first term is 14 over 9. And then when I have a geometric, this is my r value. The base of the exponent is my r value. So my r value I know is 7 over 9. So I'm going to write that finite summation formula using the geometric formula. So my first term is 14 over 9 times 7/9 to the n minus 1 over 7/9 minus 1. Again, I want to look at this graph. So taking a look at this graph, what we need to decide is that as we move out to the right, is this graph continually going up towards infinity, or is it leveling off to sort of a horizontal asymptote? So it's kind of hard to tell just in the window that we have here, so I'm just going to change my window a little bit and go further out to the right. So changing the window, we can see from this graph that definitely this is leveling off out to the right, and we want to figure out what is that value. So I'm going to take a look at my table. I'm going to put in some large numbers for x. So I'm going to take out these values that were in here. Put in 100. I'm going to put in 1,000. I'm going to put in 10,000. I'll put in 100,000. And you can see my answer is consistently giving me 7, so that means that I am converging to a value of 7. So we're going to say this converges, and my infinite summation is actually 7. So over here on the second one, we're going to do similarly. So remember, I'm going to plug 1 in for n, which is going to give me 1/2 times 3 to the 0, which is 1/2 plus, and we're going to plug 2 in for n, which is going to give me 3/2. I'm going to plug 3 in for n, which is going to give me 9/2, etc. So again, we knew that this one was geometric. What I know is that my first term is 1/2, and my r value is 3. And remember, I always know the r value on the geometrics because it's the base of the exponent. So I'm going to write that finite summation formula. So s sub n equals 1/2. You could use 0.5 if you prefer. 3 to the n minus 1 over 3 minus 1. And again, I'm going to look at this graph. So taking a look at this graph, what we can see is that as we move out to the right on this graph is just going up forever, which means it's divergent. So here I had a geometric, one was convergent and one was divergent. So the key to these is to look at your r value. So over here, the key is that the absolute value of r is less than 1. And over here, the key is that the absolute value of r is greater than 1. So if my absolute value of r is greater than 1, and then it's divergent. If my absolute value of r is less than 1, then it converges, and then we actually have a formula to figure out that convergence. So if we come back to this first example and we use this formula, we could have done the infinite summation is the first term, which was 14 over 9 over 1 minus r, so 1 minus 7/9. So if I calculate that, I get 7, which is what we got by looking at the graph. So this tells me that I don't have to go through all of that work. I can just use the rules that we came up with here, and then we're going to put those into our table here. So for my infinite summation, if it's arithmetic, I know that it's always divergent. If it's geometric, then I'm going to look at the absolute value of r, and if it's less than 1, then I can use this formula. Otherwise, it's divergent, and I don't have to find the summation. So 2 quick examples here for each. Determine if it's convergent or divergent, and if it's convergent, find the sum. So I look at these, and when I see that my variable is my exponent, I know that these are geometric. So this is geometric. So if it's geometric, I want to figure out what my r value is, and remember, it's always the base of the exponent. So this one's 0.75. Then I want to check, is the absolute value of r less than 1, and it is in this case. So since it is less than 1 here, I know that it's convergent. And then I can find the infinite summation by doing first term. So remember, I'm going to get the first term by plugging 1 in for my variable. In this case, that's k. So 3 times 0.75 to the 0. So that's just 3 over 1 minus my r, which I knew was 0.75, which gives me 12. Similarly, over on the second one, I know that it's geometric because the variable is the exponent. So r equals -4/5. The absolute value of r is less than 1. So I know that this is convergent, and then I can find that infinite summation. So I'm going to get that by plugging in my first term. Now remember here, I'm going to plug in, this starts with n equals 0, so when I plug 0 in for n, I'm going to get 1. So 1 over 1 minus -4/5. So remember that my r value is actually negative there, and that gives me 5/9.